so for today we're going to look at, once again, solving quadratics, but this time we're going to use method number 3, the quadratic formula. Some advantage with the quadratic formula is that it always works. No matter what the zeros turn out to be, you can always find them using this formula, including imaginary zeros. One of the disadvantages is that it is kind of a pain to plug in, and you've got to make sure you plug in your numbers right and have some kind of systematic method. I highly recommend you don't try to plug in the entire formula all in one in the calculator, even though it's possible. It is prone to a lot of mistakes though. So there's the one disadvantage, is the calculation part. Here is the quadratic formula. So I have my standard quadratic, ax squared plus bx plus c, where a is the number in front of my square, b is the coefficient in front of x, and c is your constant. Note that it's equal to what? 0. It must be equal to 0, like I mentioned yesterday, the golden rule, or this formula really doesn't work. It's based on the fact that you have your quadratic equal to 0. And here's the formula. X equals, so your zeros equal negative b plus or minus the square root of b squared minus 4ac all over 2a.
X equals negative b plus or minus square root b squared minus 4ac divided by 2a. 2a, 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 2a. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. 2a, 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 2a.
Can you tell me the objective of this lesson? Students will be able to solve quadratic equations using the quadratic formula and some simple calculations. What's the quadratic formula? Yeah, we'll get to that. But first, remove those shades and that baseball cap. The quadratic formula is the tool you use when those prime quadratics have you singing the blues. First, write your quadratic in standard form. Please be thorough. Ax squared plus bx plus c equals 0. Now we're going to solve for x using our ABCs. So get those pencils in your hands and roll. Take the square root of b squared minus 4ac. Then you add it and subtract it with the opposite of b. Take the values you get, divide them by 2a. Now you're solving the quadratic formulatic way.
So yes, our formula, negative b plus or minus square root of b squared minus 4ac all over 2a. So here's how it works. We have to make sure our quadratic is set equal to 0 and label our a, b's, and c's. A is the number in front of our x squared, the coefficient, so in this case a equals 4. B is my number in front of the x, so b equals 11, and c is my constant. No, I'm taking the negative with it, so it's a negative 20 for c. A is 4, b is 11, c is negative 20. And what we do is that we just plug that directly into the formula to get our solution. Now, like I said, this is where the hard part comes. I highly recommend you don't try to plug all of this into the calculator once. Try to do it systematically. I like to do what's inside the radical first. So I have negative 11 plus or minus the square root all over 2 times a, which in this case is 8. I want to figure out what's inside that square root. So what's 11 squared? 121 plus negative 4 times negative 20. Somebody real quick. Negative 4 times negative 20.
320.
320. So I have 121 plus 320 is 441. Now I want to see what happens if I square root that number. So what is the square root of 441? 21. Luckily for us, it came out even. So negative 11 plus or minus 21 over 8. Now what does this plus and minus mean? That means I can separate, this is a lazy man's way of writing 2 fractions. What it really is negative 11 plus 21 over 8 and negative 11 minus 21 over 8. So negative 11 plus 21 is a 10 over 8, and 10 over 8 simplifies to 5/4. Negative 11 minus 21 is negative 32 over 8, and that simplifies to a negative 4. So here we use the quadratic formula. So note that we could have graphed that quadratic here and solved my x-intercepts like we did yesterday. I see I have x-intercepts at negative 4 and 1.25, which is 5/4. Now what happens if you have a quadratic like this? X squared minus 6x plus 25 equals 0. And your first thought is to solve by graphing because that's a pretty easy method. So here's the graph of x squared minus 6x plus 25. And what do you notice about this graph? It's what?
They don't got no X.
Yeah, very good. There's no x-intercepts. So I can't find my zeros. But trust me, there are zeros. You just can't see them. So graphing does not work with that quadratic. What this means is, if you don't see x-intercepts, you must immediately go to the quadratic formula. The only other way to find what's called imaginary zeros. So let's plug it in. I have negative b, so in this case a negative, what is my b value for this quadratic?
6.
Negative 6, plus or minus the square root of b squared, so that's a negative 6 squared, minus 4 times a, what is a?
X.
No. What's the number in front of my x squared? 1. Very good. That is a 1. And what is c? 25. All over 2a. 2 times 1. Okay. Again, I highly recommend you don't try to play this all in at the same time in the calculator. I like to do it systematically. 2 negatives here makes a plus 6. Plus or minus the square root of negative 6 squared is a positive 36. Minus 4 times 25. So how much? 4 quarters makes a dollar. All over 2. Now let's do the subtraction inside the radical. So 6 plus and minus square root. What's 36 minus 100? So negative 64 over 2. What does that mean to have a negative 64? You can remember. Or it's what kind of number?
Imaginary.
Imaginary. So if you can remember, if you set your calculator correctly to the imaginary mode, you can actually do the square root of negative 64, which is 8i. So the square root of 64 is 8, and then I represents the fact that I had a negative inside of there. So this is 6 plus and minus 8i over 2. So I got rid of my radical. Last thing I need to do is simplify my fractions. So 6 goes into 2 3 times. And 8 goes into 2 4 times. So what were my zeros? They were 3 plus 4i and 3 minus 4i. Let's see if we calculate it correctly, because the hard part of the quadratic formula isn't the plugging in the part, it's the calculating part afterwards. So I have negative b, so negative what? What's my b value?
4.
Negative 4. Please don't attach that negative 4 with what was already there in the formula. It needs to be like this. That negative has to be there, and if you have a negative b value, it also comes down as well. So you get 2 negatives here, which turns that into a positive. So positive 4 in this case, plus or minus the square root of b squared, so negative 4 squared, minus 4 times a, what's the a value? 1 times c, 5, all over 2a, 2 times 1. Okay, systematically here, 4 plus or minus square root of 4 squared is 16, minus 4 times 5 is 20, 2 times 1 is 2. 4 plus or minus, what is 16 minus 20? A negative 4 over 2. Now I want to simplify the radical. What is the square root of a negative 4?
2i.
Very good, 2i over 2. Now I need to simplify my fraction. So 4 goes into 2, 2 times, and 2 goes into 2, 1 time. Did you get 2 plus I and 2 minus I?
Yeah.
What does 2 plus I and 2 minus I look like in a graph? There it is. Notice that the blue is my y-axis, the red is my x-axis. Do you see them cross the x-axis there? No. But if you make this three-dimensional, there is 2 plus I and 2 minus I. Pretty cool, huh? Next, note that if you have, note that whether or not you have imaginary zeros is really relying on what happens inside the radical, right? If it's a negative, you'll have imaginaries. If not, you'll have real numbers. So that leads us to what's called the discriminant. And notice the discriminant only looks at that part that's inside the radical, the b squared minus 4ac. Once I do that calculation, I'm going to call that d as for the discriminant. And if d is less than 0, so the number inside your radical is a negative, then you obviously will have imaginary roots. It won't have any x-intercepts. If that number inside that radical is a 0, so if I get plus or minus the square root of 0, I'm going to get one real root. That's because when you have this negative b value, you're going to add 0 and subtract 0, but that's pretty much the same thing, right? So all that plus and minus goes away, and all you have is a negative b over 2a. So you're going to have one real root. So if the number inside your radical is a 0, or calculates to a 0, you're going to end up with just one root. Graphically, what that looks like is that your quadratic, its vertex, sits right on the x-axis at one point. All other times, when d is greater than 0, you're going to have two x-intercepts. Now note, because the district burnt us on this in the TEACS test, if those are something that comes out evenly, let's say square root of 64 is 8, square root of 16 is 4, I'm going to have two real rational zeros, meaning numbers that turns into fractions. But if inside a radical your discriminant gives you something like this, crazy decimals, you're going to have two real numbers, but they're going to be two real irrational numbers. So there's two types of reals. Rationals, so it comes out evenly in the square root, or irrational, it does not come out evenly. So square root of 16 will be an example of a rational. Square root of 15 will be an example of an irrational. Basically, plug in your discriminant into the calculator, take the square root of it. Does it come out cleanly or not? You get decimals, still rational. Let's look at some examples. So again, we're only talking about the discriminant, so I'm only interested in the b squared minus 4ac, the part inside the radical. X squared minus 6x plus 9. So what is my b value here? Negative 6 minus 4 times a, which is 1, times c, which is 9. So I get 36 minus 4 times 9 is 36. That equals 0. So as far as the discriminant is concerned, the answer is at 0. 0 tells me what? Oops, gave away the answer. Tells me what? One real root. That is going to be your solution. I'm going to have one real root. And by root, I mean zeros. Depending on where you look, these are interchangeable. You'll hear roots, you'll hear zeros. It really is confusing. But they mean the same thing. Next one, b squared minus 4ac. So what is my b value here? Negative 2 minus 4 times a, which is 1, times c, 5. So that is a 4 minus 20, which equals a negative 16. So as far as my discriminant, what does a negative 16 tell me? A negative 16.
No real roots.
Very good. No real roots. It's going to have two imaginary roots. So I'm going to put 2 imaginary. Because this is the number that's going to fit inside that radical. And the square root of a negative 16 is an imaginary number. Last but not least, 6x squared minus 2x minus 3. My b squared is a negative 2 minus 4 times a times negative 3. So that is a 4 minus 6 times 4 times 3. 6 times 4 times 3. That's a negative 72. Two negatives makes a positive, so that's a 76. Now what is 76? Tell me. Two distinct real roots. So I will have two real roots, or zeros. Now what kind are they? Are they going to be rational or irrational? So go to your calculator, take the square root of that 76. I get a decimal, so they are going to be two real irrational roots. Again, we weren't ready for that on the test last year, and everybody at Side Park missed it.